All right, so this embarrassing because I have tried a few times to have this live session. I'm testing with equipment and also start a video series of advanced geometry. We're going to cover some of the facts and some of the proofs for area of a triangle. Some probably learned that in elementary school. That is a formula where the area here, usually say S, equal half of the base and then times the height. Now, for the triangle here, in the diagram, I have the big triangle ABC, and I have the shaded triangle ADC. Notice that they share the same height, right? So we make the claim here, which is very useful fact. That is, the ratio of the area, the shaded area ADC, over the big triangle ABC is simply the ratio of the base here. All right, so the base. Now notice that they share the same height. So in the formula here, the height and the constant would cancel in this ratio. So this is a very useful fact. Now we sometimes use a different form of this. We're going to have second example here with ABC triangle ABC here, right? If M is a midpoint here. Now we know that the area here ABM versus area BMC, we claim that they must equal to each other because in this triangle they share the same base AM equal ML, and the height we didn't draw it out from B to AC, they share the same height. So which means that's the ratio here, right? So AM over MC. Now similarly, in this BD over DC, we have this ratio of ABD's left-hand side versus the right-hand side. Now, what about this shaded triangle here, shaded area here, right? So if we're given that BD is 1/3 of DC, now here's the case. We're given this is 1/3, and we're given that AM equal MC. This is the midpoint. Now, what is the ratio here? Okay, the ratio of the shaded area over the big triangle, all right? Now, you do not have enough facts in order to solve this problem, but hopefully by the end of today's video, you're able to solve this problem. And you can share your answer in the chat later on. Now let's move on. So we have a variation of the simple fact. Now here, the configuration is slightly different on the left-hand side. So we have ABC triangle here, right? ABC. And we have P outside of the triangle. And we claim that the left-hand side triangle, ABP, over ACP here, is simply the ratio of the BD, the base, over DC. Now, how would you prove that? Okay, so this is left as an exercise, right? Now, another variation where P is inside here, right? So I have ABC, P is inside, and you make the connection AP and reaching out to D here, intersection with BC. We also claim this actually equation holds. In other words, this equation is true for two different cases, okay? So two cases. How would you prove that? I give you a hint. That is, we're going to rely on a property of proportional. So I highlighted here, if XY and UV has this ratio, the same ratio, then you can just add them up in the numerator and denominator. Now, for example, if you have 1 over 3 and equal, for example, 4, and let's say over 12, when you add them up, it's going to be 1 over 3. It's going to equal 1 plus 4, and this is 3 plus 12. So this is actually 5 over 15, right? So this might be useful for you to prove this fact on the left-hand side. On the right-hand side, you have similar. Okay, let's move to yet another example, a different variation. So I have ABC here, I have triangle, ABC. I have AD here, I have a P point, right, is on this line. Now, we claim that, this is also exercise, BMP, this triangle here, BPC, right, BPC, this triangle, all right, over the bigger triangle, we claim that this is actually equal 1/3. So it's of the same ratio here. Okay. How do you prove that? Also, an exercise. This is based on the original simple fact. Now, here I have ABC I have P inside here. I'm going to extend AP reaching D, BP reaching to E, CP reaching to F. I claim that I have this equation here. They add up to 1. How do I prove that? Okay, so here, let's try it. Let's try to prove it. Now, let's look at the PD. Let's look at this term here, right? So, the PD over DA, I claim that this is the area of triangle BPC over triangle ABC. Why is that the case? Okay, so this is triangle BPC here. Okay, versus the bigger triangle. Let's code this one, right? ABC here, right? So the ratio is actually here PD over AP. Okay. So similarly, we claim that for this part, PE over EB, right? So let's write it down here. We say PE over EB. Okay, let's erase this marking here. Okay, let's erase that. So here we're talking about P over the longer one, which is this one, right? B here. I claim that it is actually equal the ratio of APC over the bigger triangle ABC. Okay, so in other words, this is APC over ABC. All right, let's erase that again. Okay, so what is the final term, which is this one, PF over FC. So PF over FC. Let's mark them again. Okay, so PF, which is this part, over FC, which is the longer part. We claim that this ratio is actually ABP, right? This small area over the big triangle. So in other words, that's equal triangle A, B, P over A, B, C. So this left-hand side, you're going to add it up by using this equation here, right? So notice that the denominator is the same, is also the ABC. So denominator is the same of ABC. And this is going to be the area of 3, like BPC, triangle APC, and triangle ABP. Of course, the top add up to what? The whole triangle ABC equal to 1. Okay, that's the proof. All right? So today we're going to cover another important theorem using the area. We can prove that. That is, if you go to the brilliant.org, you're going to have the Menelaus theorem here. Right? What it says is that if you have a straight line cutting a triangle, you're going to have this results. So let's restate from here. So this is what is called Menelaus problem, maybe a theorem. Okay, so I have a straight line, and this line L, right? For example, this is maybe point M, all right? So we claim that we're gonna have AF over FB times BM times MC times CE times EA. That's equal to 1. Okay? How do we prove that? So let's look at how to memorize this pattern here, right? So there's a trick. First of all, you figure out the vertices of this triangle, right? The vertices that we're going to do is going to be A, B, and C. And then you figured out this straight line here, L, how it cut the triangle. So you're going to have, let's mark it with different color here, right? So we're going to cut with F here, right? And then the other cut here is going to be M. The other cut is going to be E, all right? So what you do is you write triangle, you write triangle vertices A, B, C, and you write in between, right? So, and this is going to be A, right? So for the AB, the cut is F. For BC, the cut is M. And then the cut is going to be, for Z is going to be E. So what you do is kind of cycling matter. So the way to write it is going to be just follow this order: AF over FB, BM over BC. So in other words, the ratio is AF over FB times, here is BM over MC, BM over MC times CE over EA equal to 1. All right? So this is going to be very useful. How do we prove that? All right? So let's figure out a proof. First of all, what are we going to do is we're going to make some connection here, right? So I am going to make a straight line here. Let's dot it, right? And I'm going to connecting A and M here, I'm also try to have dotted line here, okay? So we're going to use the area, the fact that we learned earlier for the proof. So we notice that what is AF over FB? Okay, AF over FB. We claim that we're going to be looking at the area for let me see, AF over so what we can claim is that it may not be straightforward, okay, but this area here, okay, this area is actually equal the division, the difference of the bigger one, AFB. The big one would be AFM, right, minus the smaller one, okay. Now, similarly, let's use a different color here. So this is the right-hand side here, another triangle, is also the difference between the bigger one minus the smaller one. But both would have the ratio of AF over FB. Okay, the two sides. So I claim that this is going to be equal to the area of AFM over triangle of BFM is also equal to the triangle of AFE and triangle of BFE. And then what happens is equal to AFM minus AFE, and this is BFM minus BFE. So what you're going to have is this is going to be equal to the highlighted triangle here. In other words, that's going to be equal to this part over this part, all right? So that's equal to triangle AEM over the triangle of BEM. Okay? That's AF, the first part, right? Now, how about BM over MC? So, BM over MC, right? Let's erase that. Erase all the marking here. All right, erase it. Erase that. And erase this one also, right? So here I claim that this is equal to the triangle BEM over the triangle ECM. So let's highlight it. So BEM here, right? Okay. And over ECM. It's ECM. Okay. This is a smaller one, right? So this is BM over CM. That's straightforward, right? Just the base, the ratio of the base. Now, how about the other one? CE over EA. CE over EA. Okay? So, CE, which is CE, this part here, over EA, the second part, right? So we claim that this is just the ECM, this part, over AEM. All right, the ratio is going to be the base here, right? They share the same height. So let's write it down. So that's equal to the triangle ECM over the triangle AEM. So if you multiply everything together times BM over MC times CE over EA, you're gonna plug in, right? So AEM over BEM for the first one. Now for the second one, it's gonna BM over ECM times BEM over ECM, and then times, finally it's gonna be ECM over AEM. Now you notice that everything cancels, right? That's good news. So for example, what you're gonna have is AEM and then the ECM and then BEM. Of course, that's everything equal to 1. That's a proof. Now on the billion.org, they can use a interesting property. Now we're going to try to solve a challenging problem from the brilliant.org. So here we have given this triangle 3, 4, and 6. We try to find the shaded region. Okay, so in other words, what do we have? We have this triangle here, and we have we have 3, we have 4, we have 6, and we don't know what is this part. Let's call it as X right there. So let's assume the area is X. Okay, so we'll try to find X. Menelaus Theorem. Now you may wonder, where is the triangle? Where is the line that we cut, right? Because remember, for this original theorem here, what do we have? Where is my original diagram? So usually what you want to have, you have a triangle, right? And then you have a straight line cutting through it and meeting the 9 segment, sometimes the extension of the 9 segment, right? At 3 different points. In this case, again with 3 different points. But here, do we see that? Right? Where is the triangle? Which one is the triangle? Which one is the cut? Right? So that's one we a lot of times this is how, when we try to use the theorem here, right? You need to find out where is the triangle, right? So here, actually, let me make sure I got the right number from there, right? This is a 3, 4, 6. Okay, good. This is the same here. Okay, so oh wait, what's going on here? Got it wrong. All right, so here, let's highlight the triangle here, right? Okay, so let's try to use this as a triangle, right? Okay, so and let's get the vertices. Let's call this A, yeah. Let's call this A. Let's call this B. Let's call this C. All right, this is C vertices. Remember, the way to remember it, you're gonna write A, B, C, and then you write A, right? And you write the point in between. Now, what is a 9? In this case, it's obvious, right? So the straight line would be this one, right? So this would be 9. This would be the 9L kind of cut, right? Let's do that. Okay. So this is 9L, right? We cut A, B, A and B and C, right? We cut A, B as the extension point. Let's call this point D. Okay, so I have D here. And we cut BC, BC here. BC is a 9 here. BC, we're going to be at this point. Okay, let's call it E. This is going to be E, right? And this is going to be E. E. And then we're going to say CA. CA is going to be F, right? This is going to be F. So what do we have? So we're going to have, let's write the equation here. The theorem, Menelaus Theorem tells us it's going to be AD dB times BE over EC times CF over FA, right? CF over FA equal to 1. Now, what is AD over dB? Okay, so let's look at that. So AD, let's mark it. So AD, yeah, AD over dB. Okay, dB. So it's going to be the base. We claim that this equal to area. This equal to area triangle CBD. I'm sorry. ABC is a bigger triangle over DB, which is triangle CBD. Okay. So in other words, we're talking about this triangle here. AD is a bigger one, the bigger triangle, versus CBD, which is a smaller triangle here, right? So of course, you can plug in the value here. The CBA, this equal what? CBA is equal the total, which is not a CBA, sorry, AD here. AD would be the whole thing. ACD, the triangle. This is wrong. This should be the triangle ACD. So ACD is going to be the total of the area, which is 3 plus 4 plus 6 plus X over CBD, which is 10, right? 4 plus 6. Okay. Now, what is BE over EC? Okay. So here, BE over EC, when we claim that this is the ratio of this triangle, these two, right? So this one, we're going to say that's equal to what? Equal triangle BDE over triangle CDE. In other words, this is going to be 4 over 6. Okay. What is CF over FA? CF, right, and FA. Okay. We claim that it's going to be this triangle over the other triangle. Okay. So that is the triangle CFD over the triangle AFD. Now CFD is 3 plus 6. AFD is 4 plus X equal to 1. All right, we have one equation, one unknown. We can solve for X. So let's do some math here. All right, so that's going to be 13 plus X over 10 times, this is going to be 2 over 3 times, this is going to be 9, it's going to be 4 plus X equal to 1. All right, so this would cancel, this would be 3, this would be 5. So what I have is on the top, I have 13 plus X times 3 would equal 5 times 4 plus X. Okay, try to solve this equation here. So this is going to be 39 plus 3x. They're going to equal 20 plus 5x, or 2x equal 19. So x equal 9.5. All right. So that's the answer. The answer is 9.5. All right. So we solved the problem. All right. So I'm quite for the day. So let's review. So we covered the area of a triangle, and we use the area of triangle to prove some of the common facts. For example, in this particular case, right, and some variation of that, which is in this configuration, and some of these two very useful. Not straightforward, but it's good for you to try to figure it out after the video. And we talk about Menelaus Theorem, how to use area to prove it. Use this argument here, and you check out the brilliant.org page for the other proof. All right, and we solve the problem on the brilliant.org. All right, so today is just the first video on a series of videos on advanced geometry facts. And that's it for today. Hopefully, if this quality is good, I'm going to keep the video. If not, I may have to redo it. All right, so this is the first time for me to experiment that's live with this setup. And I should just do the regular videos. All right, so appreciate your time and hope you like the video. Please like, share, and subscribe to the channel. Thank you.